Welcome back. We're going to look at atomics on this lecture. We saw that atomics are used to avoid the situation where we have to be acquiring locks and releasing locks. You remember in one of our previous tutorials where on threads where we were acquiring and releasing locks because we wanted to maintain synchronicity when we are increasing a number to have a consistent result. So instead of having to do that, Java has given us a better way of doing it using atomic variables. So as we can see here, we have a class called decrease, which extends a thread, and all it does, it increases a number, and these numbers I have defined them in here. We have integer, we have atomic integer, and they are static. So with decrease, we are decreasing. With integer here, we are decrementing and getting, although we don't really save that value, but we are decrementing it. And here we are incrementing it, and here we are incrementing. So what we want to do, we are creating 10 threads for each. And what we do is that the first thread will increase those numbers and start the 10 threads would increase the numbers, and then we also create 10 other threads to decrease the numbers. And because these are threads, this can execute in any ways, or even simultaneously. So you will see that with an integer, the result will be inconsistent. But with atomic integer, the result will always be, we see that with an integer, the result will be inconsistent. But with atomic integer, the result will be consistent, because when you call this method, it actually caters for consistency in the multi-threaded environment. We don't even need to look at how it's coded, but it does actually cater for that, so that you don't need to apply a lock for it. So if we run this code, what are we expecting? If we run this code, we see that we are incrementing this number 10 times, which should give us 10. And we see that we are decrementing it how many? 9 times. So if you increase a number 10 times and decrement it 9 times, what should we get? Obviously 1. You should ideally get 1. So for both of them, that's the expectation for both of them. So let's run this code. So I'm just gonna run this code now. You see that we get 1 for both of them, which is fine. But if you continue running this code, see now, integer is now 0. 0, 1, 1, 1, 1, 1. But the idea is that atomic integer is always 1. The other one is not really always the case that you will always find it as 1. Now it's 0 again. You see that the result is not consistent. And it's not consistent because you're not acquiring locks. So other threads are executing at the same time, and therefore they don't give us a reliable result. So let's say now we want to increment and decrement equal number of times. That means we have to get 0 here, because it's as if we did nothing. Get 0, we get 0, get 0. You might find that with, you see, now we have 1 here. Sometimes it might even give you negative numbers. When you continue running it, you will notice that you don't get reliable results for an integer. This is what AtomicInteger are solving for you. So you see we have 1 again. But for AtomicInteger, it's always giving you a reliable number, which is 0.